Hello everyone, welcome to StandardSolver. In this video, we are going to analyze the problem shown on the left side of the screen. So we have a truss shown in this shape and we have a 2 kN load acting on this truss. So, to solve this problem, let's go to the website. You can go to standardsolver.com. You reach here. So this is a frame analysis problem. So open the frame analysis. It comes with the default model. You can remove all the nodes and elements, get a clean slate. So let's start adding the nodes. So this is this point of the truss representing point A, which is node 1, which is at 0, 0. Then let's add our second one, B, which is 3 meter along the x-axis. So we add 3. So we are in SI units, so everything is in meters and kilonewton. Then let's add point C, which is further 6 meter from origin. So from A, point C is 6 meter away. So A being the origin, we are 6 meter away. Then let's enter point E and D. So E is above node 2 and 3 meter in Y direction. So 3, 3. That will give us point D. Then point D is above node 3. So X direction 6, then Y direction 3. So now we have created all the nodes. Let's create the elements. So element E1, we will put it between node N1 and N2. So N1, N2, then N2 to N3. We are just using default sections and element type as frame. We have kept the UDL 0. Then enter element A to E. So N1 to N4. Then N4 to N5. Then let's enter vertical elements, which are N2 to N4. Another one is N3 to N5. Then let's enter the diagonal element BD, which is between N2 and N5. So now we have all the elements. This being a truss analysis, these connections are rigid connections between these elements. So we need to release them and allow them to rotate around these nodes. So you can see the instruction here, how to do it. So we are going to use method 1. So what we are going to do is release the ends of all the elements, then fix the rotation of the nodes. So let's do that. So let's release all the elements so they are free to rotate. You can read this instruction note to get better understanding. So we released. So the release is denoted by this dot on the element. So all the ends are released. Now let's restrain the nodes. So, these elements will have a fixed point to rotate about. So we fixed the nodes. Okay, now we have a 2 kilonewton force acting in the negative x-axis direction. So let's apply that force at node, and we had to apply at point D, which corresponds to node N5. So, and it is going into the negative direction, so let's enter -2. So it is going towards the, towards the negative direction. Okay, and now we need to enter the restraints. So at point C, the frame is pinned, or you can say truss is pinned. So let's at node N3, let's restrain true. So you can see the rotation is also restrained. That is for allowing these members to freely rotate about these points. Like many softwares, you will see an option called end release. This has the same effect. Even though we have fixed the rotation, but these elements are free to rotate around it, we have a hinge joint. Then at node N1, the structure is free to move laterally, but it cannot move vertically down. And we are not in the so let's restrain it in Y. So now you can see it is restrained in Y direction, so it cannot go up or down, but it can move laterally. Recenter it. Then let us run the analysis. So this is the results, and let's see what results we got, how it is compared. So we are seeing AB, element AB is this one. It has 1 kilonewton. Zoom in at element AB. You can see AB is this element, and it has a 1 kilonewton here. Then element BE. B is this vertical element. It also has 1. You can see 1 kilonewton here. Then CD. CD is the vertical element. It also has 1. You can see 1 in orange here, representing this element. So the blue actually means they are in tension, if I remember correctly. Then red is red when they are in compression. So AE element, we have a compressive force of 1.4, which is the answer. So yeah, this is the answer we are looking for. And you can see we got the same answer. Then I think there is a few other answers. I missed pasting there, but let me paste it now. Which is BC is 2 kilonewton, BC. So let's zoom into so BC, you can see 2 kilonewton, and the DE DE is the vertical element. And let's zoom into there. So D is 1. So you can see how we solve this problem using StandardSolver. Then once you're happy with it, you can download the report of what you did. And if you open, you can see the the solution you had. What I'll do, I'll attach the solution to the description section so you can have the solution. So in future you want to go through this solution, you can upload the results and see it again using this upload. So just download that file, then upload it to the StandardSolver, then it will recreate everything for you so you can give it a try yourself. So yeah, that's it guys. So give it a try. So have a good day.